Net change of population over time given a function that represents the rate of change of population in a city over 4 decades from 1800s to 2020. So that means the t is between 0 to 4. And then here is the rate of change function. So we have r of t equals to 1200 t squared minus 1300 times t plus 2000. So if you plug in, let's say you plug in t equals to 2, so you plug in t equals to 2 to the rate of change function, that will tells you the rate of change of the population at during a specific time. My question is, determine the net change in population over decades from 2000 to 2020. So that means t is between 2 to 4. So all you have to do is you take the integral, and then the t goes from 2 to 4, and then 1200 t squared minus 1300 t, and then plus 2000, and then dt. Okay, let's just integrate. So this one we have t plus 1, so that is t to the third, and then we have a 1200 divided by 3, right? So we have a 1200 divided by 3, and then minus t squared, and then we have a 1300 divided by 2, and then plus 2000 t, and then such that t goes from 2 to 4. Now, at this point, after you finish the integration, we obtain a function that tells me the population at a specific time. So that function is, so let me just put this in a different color. So this, the R stands for rate of change, right? So for the population function, I will just call that P of t. So the P of t, that is equals to 1200 divided by 3, so that is a 400 t to the third, and then you minus 650 t squared, and then plus 2000 t. This is the population function. So now, how do we use this? So let's say when t is equals to 2, so when t is equals to 2, that means in year 2000, right? That means in year 2000. So pt of 2, when t is equals to 2, so you plug in a 2, you will get a number, right? So you will get a number. This is the population at year 2000. That gives you the population. However, if you plug in t equals to 2 to the r of t, that gives you the rate of change of the population. Okay, that is not the population, that is the rate of change of population. If you want to know how many people are in the city during year of 2000, you have to plug that into P of t. Okay, let me go ahead and finish the definite integral. So we have 400, right? So we have 400 t to the third, and then minus 650 t squared, and then plus 2000 t, such that t goes from 2 to 4 using fundamental theorem of calculus. Using that will be using the upper limit minus lower limit. So you have 400 and then 4 to the third minus 650 4 squared, and then plus 2000 times 4. So this is the upper limit, and then you subtract the lower limit, right? Let's put that okay, I can just write across. So this is a 400 and then 2 to the third minus 650 2 to the second, and then plus 2000 times 2. So this one, all this gives me 18,600. So this is the net change. Right, so this is the net change. What is the net change mean? So let me explain this using this method. So let me change to a different color. So in application, there are two words that you have to understand. The first word is called displacement. Displacement means where you are, and then from displacement to rate of change. Displacement can be represented by a function. Rate of change can be represented by a function. From displacement to rate of change, all you have to do is you take the derivative. So let's say the displacement function is f of x equals to x squared, and then the rate of change of x squared is f prime of x, that is equals to 2x. Okay, and then how about from rate of change back to displacement? Let's switch to a different color. How about from rate of change, let's call that just ROC, rate of change, all right, back to displacement. All you have to do is you take the integral. So let me give you an example. So let's say the rate of change, the rate of change is how about 2x, and then what's the displacement function? The displacement function is the integral of 2x dx, that is equals to x squared. All right, so how about the net change? So let me give you a graph of x squared. So the x squared is a parabola, right? So x squared is a parabola, and then when x is equals to 0, y is equals to 0. And then when x is equals to 2, when x is equals to 2, y is equals to 4, because 2 squared is equals to 4. Okay, now, from x equals to 0 to x equals to 2, what's the net change? So we are trying to find the net change from x equals to 0 to x equals to 4. So all you have to do is you do the integral from 0 to 2, and then the 2x, right? And then dx. So first you will obtain the displacement function x squared, such that x goes from 0 to 2. And then you plug in the 2, right? So that is a 2 squared minus 0 squared, that is equals to 4. So what does that mean? So let's say we put the x squared as population. So when x is equals to when x is equals to 0 and when x is equals to 2, what was the population when x is equals to 0? The population, so you plug in a 0, then you get a 0, right? Y is equals to 0. And then you plug in a 0, y is equals to 2 squared, that is equals to 4. So this is the initial, and then this is the terminal. Just imagine that we have a time interval from the initial point to the terminal point. What's the net change? The net change is you use 4 minus 0, that is equals to 4. So if you are talking about population, that means from time 0 to time 2, the population is increased by 4. At time 0, you have a population. At time equals to 0, you tell me where you are. At time equals to 2, you tell me where you are. I use the y, the corresponding y for y equals to 2 minus the y when x is equals to 0, the population is 4. That means from time 0 to time 2, we gain 4 people. So that's how you interpret the net change. All right, so if you think this is helpful and clear, give me a like, share, and subscribe. I truly appreciate your help. I will catch you all in the next lesson. Signing out.